For the next one, I'm looking for f of g and then g of f. So for this first one, f of g is like f of g of x. And what this tells me is that I'm starting with the x values, and I'm using the x values from the g function, because I have g of x inside there. So if I look at the x values from the g function, I've got 4, 0, and negative 2. So here's what I'm going to do. This is going to equal, I'm going to start with the 4. If I plugged a 4 into this function, it would spit out a 5. See, so over here, this is like our chain reaction problem. If I plug a 4 in, it's going to give me a 5 out. All right? And now if I come over to the f function, I'm plugging a 5 into the f function, the 5 would then connect to a 4. So basically I started with a 4 and ended with a 4, so it's the order pair 4, 4. If I look at the next one, the x value is 0. The 0 connects to the 1, and then over here 1 connects to another 0. So I started with a 0, ended on a 0, so it's 0, 0. Then the last one, the negative 2 connects to the 2. Over here the 2 connects to the negative 2, so I started with a negative 2. I ended with a negative 2, so it's negative 2, negative 2. So that's the composition of f of g of x. Okay? For the next one, I'm doing the same thing but in reverse. This time I want g of f of x. And what this tells me is that I'm starting with the x, and I'm using the x values from my f of x function. So again, I'll start with the f of x this time. So I'm looking at the 1, the 2, and the 5. So I start with the 1. Again, 1 connects to the 0. Over here, 0 connects to the 1. So it ends up being the ordered pair 1, 1. Next one, 2 connects to the negative 2. Negative 2 connects to the positive 2. So I started with a 2, ended with a 2, so it's 2, 2. And then the last one, I'm starting with the 5. 5 connects to the 4. 4 connects to the 5. So it's 5, 5. And that's it, right? And it's just a coincidence. This is just a coincidence that it ended up being 1, 1, 2, 2, and 5, 5. And again, the last situation we need to worry about as we're working through these problems is if any of the chain reactions don't work, if they don't bring us to a y value, if they kind of stop short, what we say is that the composition does not exist. So we write down D and E. If I take a look at the next one, it says given f of x equals 2/5 x minus 2, we want to find f to the negative 1 of x. And again, this is just a notation for our inverse. So that means we're looking for the inverse. So right here, this guy really means, actually let me bring it over here a little bit. F of x is the same thing as y, so y equals 2/5 x minus 2. And to find the inverse, we just switch the x and the y. So here, they're just going to trade places. So instead of y equals, I'm going to have x equals. Instead of a 2/5 x, I'm going to have a 2/5 y, then minus 2. And then the only thing I have to do here, I just have to solve for y. So I'm going to add the 2 to each side. So I've got x plus 2 equals 2/5 y. And now from here, I could multiply each side by the reciprocal, by 5/2. But a lot of people find that intimidating, so I'm going to show you another way. What I can do to get rid of the fraction, this is like 2 divided by 5. Let's multiply each side by 5 to get rid of the fraction. So here the 5's cancel. You're left with a 5x plus 10 equals 2y. And now I'm going to divide each side by 2. Right? So essentially what I'm doing is multiplying by the reciprocal, but I'm doing it in 2 steps. So that's 5/2 x plus 5 equal to my y value. Don't forget to write it back in the function notation. Over here, remember, the inverse is f to the negative 1 of x equals, that's 5/2 x plus 5. And that's it. All there is to it. If I look at the next one, for this next guy, it says given f of x equals 1/2 x plus 2 and g of x equals 2x minus 4, we want to know, are these inverses of one another? And to find out if they are inverses, I'm going to do my composition test. So I'm going to do f of g of x. And when I'm done with that, I'm going to do g of f of x. And the idea here is that when I do the composition each way, if I simplify this to just an x each time, then they are inverses of one another. So if I look at the first one, f of g of x, well, f of g of x is the 2x minus 4. Well, f of x is 1/2 x plus 2. But instead of an x, I'm going to plug in whatever's in the parentheses. So I plug in the 2x minus 4. And I would just have to simplify. I distribute the 1/2. That's going to give me an x minus 2. Sorry, this guy up here was a plus 2. So that's going to give me an x minus 2. I still have the plus 2. And now I combine like terms. That was a close one. I copied down the problem wrong. And I find out that that simplifies to just x. And that's the thing I'm looking for. If I don't get x here, I don't bother doing the second composition. Okay, since I did get x, I'm going to move on to the next composition. So I'm going to do g of f of x. Well, f of x is the 1/2 x plus 2. G of x was the 2x minus 4. But instead of x, I'm going to plug in whatever's in the parentheses, which is the 1/2 x plus 2. And I would just need to simplify. Here I'm going to distribute the 2. That's going to give me an x plus 4. And then minus 4, I combine like terms, I'm left with just x. Since I'm left with just an x each time, the composition test, it passes the composition test, so I know that these two are inverses of each other. So I'm going to say yes. Yes, they are inverses. Okay? The other way to do that is you could find the inverse of each and see if it matches the other function. For this next one, we're using this graph to find the distance. And right here, I want the distance between j and n. And so what I'm going to do here is I'm simply going to count and then use my Pythagorean theorem. If I complete this right here, what I end up having is a right triangle. And I can find the distance using the Pythagorean theorem because I have a right triangle. So I just have to count this side as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. And this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. So now the Pythagorean theorem is a squared plus b squared equals c squared. So that's 10 squared plus 12 squared equals c squared. So that's 100 plus 144 equals c squared. So that's 244 equals c squared. And now I have to take the square root of each side. And the other thing I have to be careful about here is I've just got to simplify this. The square root then of 244, which is kind of my answer, but I've got to simplify it. That's the same thing as 4 times 61. And now the square root of 4 is 2. It escapes to the outside. It's a changed number on the outside, but the 61 is still trapped. So that's my final answer, is 2 root 61. For the next one, I'm going to do something very similar. I'm looking for n to s. So I'm going to erase this and do it again. So n to s is right here. Again, I complete the right triangle. It's not a very nice looking triangle, but that's okay. Over here, the distance of 2. Over here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost ran out of fingers there. I was close. So I've got a squared plus b squared equals c squared. So I've got 2 squared plus 9 squared equals c squared. So that's 4 plus 81 equals c squared. So that's 85 equals c squared. And now I take the square root of each side. And really, there's no perfect squares that divide evenly into 85. So I'm just going to leave it the way it is as the square root of 85. And that's it. We're done. Okay? So again, when it's graphed, we want to use our Pythagorean theorem. When it's not graphed, when we're given ordered pairs, like in these two examples, we're going to use our distance formula. Remember, the distance formula is like a tank. Okay, this is a difficult formula to mess up. Just got to make sure you plug in the x's for x and the y's for y. All right, so for number 14, I want the distance and then the midpoint. So to find the distance, I just plug it into my distance formula. So that's going to be a negative 1 plus 0 squared plus the y values are the 3 and the 5, so 3 minus 5 squared. And I just have to simplify it. That's going to be a negative 1 squared. I don't know why I put a plus in there. Not that it matters, but write it correctly, Mr. Jansen. Come on. So negative 2 squared equals, that's going to be 1 plus 4. and that's going to give me the square root of 5, which I can't simplify, so that's my distance. All right. The other thing I need to find is my midpoint. So again, I just use my midpoint formula. I add the x values together, -1 plus 0 divided by 2. I add the y values together, 5 plus 3, or really I could do 3 plus 5. And again, this one's difficult to mess up. All right, you just got to plug it in. X is for x, y is for y's. And now I just simplify. This reduces to a -1/2. This 3 plus 5 is 8 divided by 2 is 4. So that's my midpoint. Okay, distance and midpoint. If I look at the next one, I'm going to do the same thing. Distance equals the square root of. Here, this is 4 minus a -2 squared plus 3 minus 3 squared. That is a 2, I promise. Let me try again. Yeah, there we go. So here that's like plus a positive, so that's a 6 squared plus 0 squared. So what I end up with is 36 plus 0. So I've got the square root of 36, which is 6. So my distance here is 6. And if you notice, because the 3 is repeated, these are points that are lined up. I could have just counted from one to the other. Distance from 4 to -2 is 6. And then the last thing I want to do is my midpoint. Again, my midpoint, I use my midpoint formula. So 4 plus a -2 divided by 2. And then the y value is 3 plus 3 divided by 2. And when I simplify this, I find out that my midpoint, let's see, that's going to be a 2 divided by 2 is 1. That's going to be a 6 divided by 2, which is 3. So the midpoint is 1, 3. And that's it. That's all there is to it. A little bit of plug and chug, and you're done. I hope this was helpful, and good luck on your test tomorrow.